Here we're being asked to find the absolute max and min value of the following function on the given interval. So there's a strategy for finding a absolute max value. So that's a y value, by the way. But the strategy is that whenever you're given something, you can have an absolute max either at any of your critical points, or you can have it at any of your endpoints. So ultimately, we're going to have to plug in our endpoints, which means we're going to have to plug in -1 and 1. But we're also going to need to plug in whatever our critical numbers are. So we're going to have to figure out what those are, and we're going to plug them in, and whichever one comes out the biggest, that's going to be our absolute max. Okay, but to find your critical numbers, you need to take the derivative and set it equal to 0, and also find out wherever it doesn't exist, but the original does exist. But usually it's just set equal 0. So when I take the derivative here, I'm going to end up with 2x plus 1 over x squared plus x plus 1. And now I'm going to set that equal to 0. And just checking the thing about where it doesn't exist. Well, this thing is not like easy to factor, so setting that equal to 0 would be a little bit of a pain. But if you did solve that, that would tell you where it doesn't exist. But x squared plus x plus 1 can't actually equal 0. If you think about how ln works, you can never actually get ln of 0. So that's a small little detail. What mostly matters is just trying to solve this equation now. And you can put this one over 1 and cross multiply, and you'll just end up getting 2x plus 1 equals 0. And that would mean x would equal -1/2. So that's your critical number. So at this point, all we have to do is plug in -1, plug in 1, plug in -1/2. All right, so I'm going to start with plugging in 1. That should be on the easier side of things. So I'm plugging this into the original function, and that's going to be 1 plus 1 plus 1, that's ln 3. If I plug in -1, that's going to be ln of -1 squared, which is 1, minus 1 plus 1. And these cancel out, and I just get ln of 1. And ln of 1 is 0. And now I gotta plug in f of -1/2. That's ln of 1/4 minus 1/2 plus 1, which is ln of -1/4 plus 1, which is ln of 3/4. And ln is an increasing function. So when you're looking at the graph of ln, the bigger the number that you input, the bigger number you output. So whichever one has the biggest input is going to be the biggest. So ln 3, that's going to be the biggest. And that's what's called our absolute max value. So we're just going to say that the absolute max value equals ln 3. And that's what they wanted. And now I need the absolute minimum value. So I'm just going to say the absolute minimum value, and you might have already guessed this, is ln of 3/4. And that's it. That's all I had to do here. So plug in your endpoints, plug in your critical numbers, see which one comes out the biggest, see which one comes out the smallest, and then when they say the word value, that means you're after the y values. All right, I'm out of here.